Hi, Gr12. Greetings to everyone. Welcome to Edublash Visual Academy. My name is Makore. I'm going to be presenting a section under functions and graphs. Okay, functions and graphs. This is lesson 6. In lesson 5, I was basically looking at the inverse of a function. Under section 5, we looked at the inverse of a function, and we said there are two types of there are two methods that we can use to deduce the inverse of a function. The first one, it is the algebraic method. The second one, it is the graphical method. I looked at the algebraic method, and just to go through a quick review under inverse of a function algebraically, we said there are 3 steps that we can use to deduce the inverse of a function algebraically. The first one was to interchange variables. After interchanging variables, you said we should make y subject. After making y subject, the last thing is to make, if necessary, substitute y with f inverse. Okay, that's what we did in the previous lesson, and I promise that I'm going to do the inverse of a function, but graphically. Okay, but before I look at the inverse of a function graphically, there is one review class that I'm supposed to do, which is determining the domain and the range of a function. Domain and range of a what? The function. This is something that we did in the lower grades. We looked at the domain and the range as early as starting in grade 8 and 9, where we were talking about the inputs, the outputs. Then in grade 10, we started defining the domain of a function properly. Okay, right, domain and range. So I'm going to be looking at a quick lesson, a prerequisite to determining the inverse of a function graphically. I have to show you how to come up with the domain and the range. Otherwise, when I'll be explaining that part, you get lost if you do not have that grounded properly. And it is a very, very, very important component. Your examiners are very interested in seeing how you guys appreciate the domain and the range of a function. Okay, right. Let me take you to the board so that we can start with our lesson. I hope you enjoy this, and let's unpack it together. It's just class. I hope and pray that you love this. You love this. So I'm going to say domain and what? And your range. So I'm going to say this is under functions, and your graphs. Under functions and their graphs. Okay, right. Now look at this. Let me start by defining what domain is. What's domain? What is it that I'm saying domain? Now, the definition of a domain, I'm going to say domain of a function. It is where the graph starts and ends. This is where the graph starts and ends along the x-axis. So when a graph is drawn and we want to define or we want to deduce the domain, I'm going to trace my graph and I'm going to say this is where the graph starts and ends along the what? The x-axis. Given a drawn graph, let me give you a quick illustration. I've got something like this. This is my Cartesian plane. Look at that. This is the y-axis. This is the x-axis. I've got a drawn graph. Let's try to look at this together. There is my drawn graph. I've got a coordinate there. Label that coordinate to be -2 and 1. I'm going to label this as 3 and 4. Right. Now, I want us to analyze this. What is it that we are calling the domain? Domain, it is where the graph starts and where the graph ends along the what? The x-axis. So I'm going to say, where does this graph start? Where does it start? So when I'm talking about where it starts, it means I'm looking at the minimum value along the x-axis and the maximum value along the x-axis. Numbers, they increase from negative infinity to positive infinity. Or I can say numbers, they increase from left going to right. So I'm going to trace my graph from the left. If you look at your graph from the left, you can see that this graph starts at -2 along the x-axis. And where does it end? You can see that dotted line shows that it ends at what? At 3 along the x-axis. So the domain of this graph is from -2 to +3. That's what we are calling the domain. So domain to this graph, if I use capital letter D there, it means if I'm to write it, remember there are 3 different ways to present something, an interval. You can put it in inequality form, which is set builder notation. You can put it in interval notation. You can also put it on a number line. Okay, so if I am to put this, or if I'm going to present it using inequalities, it means I'm going to say you are starting from -2 less or equal to x less or equal to 3. You can see that they are end not there to show that -2 and 3, they are part of the interval. Or someone can present it as interval notation, where you are saying x is an element of, you put a square bracket because -2 is included, up to 3 close bracket, something like that. This is what we call the domain. Define it. This is where the graph starts and ends along the what? The x-axis, meaning to say my domain starts there and it ends there with that arrow. That's what we are calling the domain of a function, where the graph starts and where it ends along the x-axis. Or algebraically, we are saying, algebraically, look at the definition. Algebraically, we say this is where the function is defined along the x-axis. So domain is read or is deduced along the x-axis. Okay, right. Let's come to the range. Let's come to the range of a function. Range. What is it that we are calling range? I'm sure you can now define it the technical way. We say it is where the graph, this is where the graph starts and ends along the y-axis. Okay, same thing, but I'm now reasoning along the y-axis. We are saying this is where the graph starts and where it ends along the what? The y-axis. So if I come to my Cartesian plane and try to draw my Cartesian plane like that, look at that, then I'm also going to draw a line. Okay, I'm also going to draw a graph, any. Okay, let me change a little bit. So if I'm to draw something like this, just for a change, you've got something like 1, 1 and 2. Then this side, I now have what? -2 and 4, something like that. Okay, right. Then I'll say determine the domain of this graph. Domain is where the graph starts and ends along the y-axis. So if you go to your y-axis, remember numbers, they increase from the bottom going to the top. So you start from the bottom. The smallest possible value of y along according to this graph, it is actually what? 2, which is this y coordinate. So it starts from 2. Where does it end? Look at that, look at that, look at that dotted line. It ends at 4. So from this point 2 up to 4, this is where the graph starts and ends along the what? The y-axis. So it means the range to this the range, I'll use capital letter R, the range to our graph is where we are saying 2 is less or equal to y this time, less or equal to 4, that kind of a thing. Or someone can actually present it in interval notation as y is an element of all real numbers from 2 up to 4, something like that. That is what we call the range, and that's how you deduce. Okay, let me just quickly give you an example. Let me just give you an example to this. Then I'll give you an activity. Example 1. Let's look at this. Let's look at this. Right. Example 1. Let's look at your example number 1. I'm going to draw a graph there. Right. I'm just going to go through your graphs so that whenever you are faced with such a problem, you do not have challenges with determining the domain and the range. Okay, let's look at this example. Let's look at this example. Right. Allow me to write it again this side for the sake of my space. I'll say this is my example number 1. Determine the domain and range of f. Right. Now let's look at this. Let's look at this. I've got a graph like this. There is my graph. Okay. I've got a graph like that. Slightly different from the illustration that I was making. But in this case, look at this one. This is an exponential function, but the left-hand side is restricted. It starts there. I'll call this -2 and 1, something like that. Okay, right. Now look at this. Question says determine the domain and the range of this graph. Determine the domain and the range of your graph. Now, how do I determine the domain? From the definition, this is a drawn graph. Look at this. Where does the graph start? That's the question that you should ask yourself. It starts from negative. It starts from the left side going to the right side. Right. This is where the graph starts and ends along the what? The x-axis. Now, if I come to the left side of the graph, where does it start? I'm going to draw a vertical line. You can see that this graph starts where? At -2. That's where it starts because there's an end node there. Now, where does it end? It's going to end, draw a vertical line, right? But when I draw a vertical line this side, this time there is no number. In other words, there's an arrow. That arrow shows that the graph proceeds, it continues. But where is it going? It means it's going towards positive infinity along the x-axis, that is. So this graph starts at -2, and where does it end? Positive infinity. So someone using inequality signs can just come and say this means the domain to this graph is x greater than or equal to -2. Numbers that are greater or equal to -2, which ones are those? -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, up to and including what? Infinity. So in short, you can just say x is an element of all real numbers that are greater than -2. Or if you are to present it using interval notation, someone can just say x is an element of all real numbers from -2 right up to infinity, something like that. What about its range? What about it? Allow me to write the range this side. Okay, the range. How do I get the range of this? Where does the graph start? You analyze it from the bottom to top. So what is the smallest y value? I'll come and draw a dotted line there. The smallest y value there is 1. So I'm going to say it starts at 1. Where does it end? You trace the graph up where does it end? You are going to draw a horizontal line right at the top, but you still see there is a what? An arrow, and that arrow shows that the graph continues up to positive infinity along the what? The y-axis. Remember this side, that's where the positive infinity for y is. So the graph starts at 1 along y up to infinity along y. So range, it is where the graph starts and where it ends along the y-axis. So it means someone can just come and say range this time, so this is y greater or equal to 1. Or if you are to put it in interval notation, still y element of what? All real numbers from 1 right up to positive infinity. Okay, right. That was example number 1. Let's go to example number 2. Still, I'm looking at what? The domain and range of a drawn graph. Okay, determine the domain and range of the following functions or the following graphs. Okay, right. I've got 2 graphs there that I just want us to run with. Still doing the same thing. I've got one which is of this sort. Right, there it is. What type of a graph is that? That's a bell-shaped parabola. That is a bell-shaped parabola or set face parabola. Okay, then the second one, which is your B, it is something of this sort. Okay. Okay, then I've got a graph of this sort. Allow me to do this. Labeled y equal to 1, then it's an exponential function of that sort. That is 2. Okay, right. Let me start with these 2. Just determining the domain and the range of these graphs. Domain and range. Right. Now, what is the domain of the first one, which is A? What am I going to do? I'm going to trace it from the left. Draw a vertical line where the graph starts. That's where you go. This is where it starts. But there's an arrow there. It shows this thing continues. But when it continues like that, it comes towards negative infinity along the x-axis. So it starts at negative infinity. Then I'll also come and draw a vertical line where it ends. Where does it end? There's an arrow as well. So it means this is going towards what? Positive infinity. It's not bounded along the what? The x-axis. So someone can say the domain to this graph, it is what? From negative infinity to positive infinity along what? The x-axis. If I'm to present this, I'll just say, since it takes values from negative infinity to positive infinity, someone can just say this is x element of all real numbers, meaning to say x can be any number from negative infinity to positive infinity. Or if you are to write it as interval notation, you can just say x is an element of all numbers from negative infinity to positive infinity. Okay, you choose whichever way you want to present it, but not both. Okay, right. Now come to range of this function. What is going to be the range? Where does it start? Along the what? The y-axis. That's your question. So you analyze the graph from bottom. Where does it start? At the bottom. You can see that there are arrows as well. This means it goes to what? Negative infinity. But where does it end? Look at this. It ends at 3 along y. So it starts at negative infinity, ending at what? At 3. So it means the graph will take all values that are less than or equal to 3. Why? Because if that is 3, this is the maximum turning point. This graph does not go further than 3. This is where the graph ends along the y-axis, and all the values that it takes from negative infinity right up to 3, they are smaller than y. So I'll come and say my range is y less or equal to 3 because it passes through 3. Or in interval notation, you can say y is an element of all real numbers, put an open bracket, which is from negative infinity right up to 3, you put a square bracket. You always put an open bracket where there is infinity or negative infinity, okay? Right, now that is how you determine the domain and the range of that parabola. Come to B, determine the domain and the range of that drawn graph. That graph is an exponential function which is increasing, okay? Right, anyway, determine the domain. What is domain? Where the graph starts and ends along the what? The x-axis. So I'm going to draw vertical line where it starts, but if you look at this, there is no arrow, there is no number which is written. So in such a case, you come and put your own arrow to show that the graph is not starting where the vertical line is. Where does this arrow show points at? At negative infinity. So this is going to negative infinity. Where does it end? Look at this. It ends at what? Positive infinity. If you put an arrow there, it shows that it's not stopping, it's continuing. So it's also going towards what? Positive infinity. So it means it takes values from negative infinity to positive infinity. So it means the domain of this is x element of all real numbers. Or you can write it also in interval notation as what? X is an element of negative all real numbers from negative infinity to positive infinity. I'm just giving you these two alternative solutions. You can present it in any other solution that you can think of as long as it points to the same thing. But in an exam, you're expected just to pick one, not both. Okay, right. Now, what about the range? Where does the graph start? Where does it start? You can see that this graph, it's an exponential graph. Its asymptote is y equal to 1. Remember, the graph does not start, touch the asymptote, but it starts right after the asymptote, right on top of the asymptote, ending where? To positive infinity at the top. That side, it ends where? Positive infinity. So it means the range to this is what? Y greater than 1. You can't say or equal to because it's an asymptote. So it starts slightly above y equal to 1, right up to what? Infinity. So I can safely represent that interval as y greater than what? 1. It means the graph starts somewhere above 1, which is 2, 3, 4, 5, 6, up to and including infinity. You can also present it as interval notation. It's fine, but for now, I'm going to leave it like that, okay? You can just say y, this is y element of, open a bracket, 1 right up to infinity, okay? That's another way to present the domain and the range of that. Okay, now I'm also going to give you yet another example. Remember, I'm trying to exhaust on this component so that whenever I'm now applying this thing in the next lessons or in the coming lessons, you guys, you will not struggle with this. Right, let's look at another graph. Okay, let's look at another graph. You are given a graph of this sort. The question is still the same. Determine the what? The domain and range, right? Just call it example. Just call it example number 3, right? Example number 3a, there's a graph which is drawn. There is your graph, right? On this graph, let me draw this. This is x equal to 1. That is y equal to 2. I'm sure you can appreciate that graph. Yes, that is the graph that I'm talking about. What type of a graph is this one? This is what we call a what? A hyperbolic function. This is a hyperbolic function, right? I'm trying to come up with the domain of a hyperbolic function. I'm trying to come up with the domain and the range of a hyperbolic function. Domain and range of a hyperbolic function. Remember, a hyperbolic function is a discontinuous function. This is a discontinuous function. Okay, right. That is a discontinuous function. Right. What do I mean when I'm saying it's a discontinuous function? A discontinuous function, it is a function that you cannot draw without lifting the pen up. A continuous function, opposite to discontinuous, it is a function that you can draw without lifting up the pen, like in a linear line. You can just join those points without lifting the ruler up. But on a hyperbolic function, this is purely grade 10, right? But on a hyperbolic function, you cannot draw those holes from the first quadrant to third quadrant, or second quadrant to fourth quadrant, that kind of a thing. Okay, right. So let's look at how I'm going to come up with the domain and range of this one. Right, domain. I'm going to start with my domain. How do I get the domain of this function? Where does the graph start? That's the question. So I'm going to draw a vertical line starting from the left, going to the right. Now, if you look at this, you can see that there is an arrow there. Even if there's no arrow, appreciate that there will be an arrow there. You can put it on your own. This shows that the graph is going towards negative infinity along the x-axis. Okay, now come to this side. Where does it end? You can see that it goes also to positive infinity. So this graph starts where? From negative infinity to positive infinity, which means x is an element of all real numbers. But whenever you are stating the domain of a hyperbolic function, you have to appreciate that this is not a continuous function. So there should be a what? An asymptote. There are two asymptotes on a hyperbolic function, one which is vertical and the other one which is horizontal. So if you look at from negative infinity to positive infinity along the x-axis, there is a restriction which is at x equal to 1, meaning to say the graph will never touch x equal to 1. It's an asymptote. So you come and put a semicolon, or you can say but x should not be equal to 1, that kind of a thing. That is a restriction there. It's an asymptote. The graph will never touch that. That's why when I defined it, I gave you two definitions, and the second one says what? The first one says where the graph starts and ends along the what? The x-axis. The second one says where the graph is defined along the what? The x-axis. So in this case, at x equal to 1, the graph is not defined there. Okay, right. What about range? What about range? The range of this function, the same thing. I'm going to start from the bottom. If you start from the bottom, this is where the graph starts, but there's an arrow there. So it means this is going towards what? Negative infinity. Where does it end? Right at the top there. It's not bounded. There's an arrow, so it goes towards what? Positive infinity. So it also starts from negative infinity to positive infinity. In short, I can say y is an element of all real numbers. But y should not be equal to what? Y is not equal to 2, because horizontally at y equal to 2, the graph is not touching that. In other words, it's an asymptote. Okay, right. Now let's come to yet another example, just to emphasize on the domain and the range of a function. Look at this one now. Look at this one. What type of a graph is that one? That's a logarithmic graph. That's the graph of a logarithm. You will explore on this one as we go, but that's an increasing logarithmic graph. Fine. Right. Let me get its domain. What is the domain of this graph? The domain of this graph, this is where the graph starts, and this is where the graph ends along the what? The x-axis. Where does it start? You trace it from negative infinity. You can see that from negative infinity, the graph is not there. The graph is only starting after the line x equal to 1. x equal to 0. Sorry about that. Okay, x equal to 0, which is the y-axis. So it starts at x equal to 0. Where does it end? It ends at positive infinity. So the graph starts just after x equal to 1. It's an asymptote as well. You can see that the graph is approaching x equal to 1, but it's not touching it. It starts right after x equal to 0. So from x equal, don't worry about x equal to 1. The graph passes through there. It starts at somewhere after 0. Okay, so the domain to this, if I am to present it, I can just say x is greater than what? 1. Meaning to say greater than 0. Meaning to say after 0, that's where it starts, and it goes towards what? Positive infinity. So I can just say x is greater than what? A 0. Okay, what about its range? Where does it start along the y-axis? I'll come to the bottom part. You can see that there is an arrow there, so it's going towards negative infinity along y. What about at the top there? You can see that there's an arrow as well, so it goes towards positive infinity as well. It's not bounded. So if someone can just say y is an element of all real numbers, meaning to say from negative infinity right up to positive infinity. That's domain, that is range of a function. If you are given any graph that you can think of, you should be able to deduce what its domain is and what is its range. Okay, just a last one, just a quick one. That's a parabola. This is 3 and -1, something like that. Then someone will come and say, determine its domain, determine its range. Okay, right, determine the domain, determine the range. Okay, I've got this labeled as say 2. Where does the graph start? That's the most important thing. Along the x-axis and along the x-axis, it starts. You come and draw a vertical line where it starts. You start from negative going to the positive. From left going to what? Right. You can see that it's not bounded. There's an arrow there, meaning to say the graph continues. And as it continues, it's coming towards negative infinity along the x-axis. Okay, right. So where does it start? Negative. Where does it end? There you go. It shows that it's not bounded. There's an arrow there, meaning to say it goes, it continues. And as it continues, it's approaching what? Positive infinity along the x-axis. So it starts from negative infinity to positive infinity. And this is a continuous graph. If I insert my pen like that, I will draw this graph without even lifting the pen up. Okay, right. So that means the domain to this is what? X element of all real numbers. Okay, right. Now, come to your range. How do I get the range of this function? Where does it start? Where does it end? It starts at what? From bottom, draw a horizontal line. You can see that it starts there. And what is the y coordinate there where it starts? It is -1. So it starts at -1. Where does it end? I'll go up horizontally. Look at that. This graph shows that the arrows, they can prove that it's going towards what? Positive infinity along what? The y, along the y-axis. So it means I can say it starts at -1 and it ends at positive infinity. That is an inequality. I can just say y is greater or equal to -1. That would be the range of this particular graph. Okay, now that is how you come up with the domain and range of a function. Okay, just as an activity, I'm just going to give you 1 or 2 here. Then I'm also going to post more and more graphs that you are supposed to consider and determine their domain and their range. Okay, so it just as an activity there, activity. Okay, determine the domain and range of f of x in each case. Right, I'm just simply going to draw those things. Right, the first one, look at this graph. look at that graph. Just apply the knowledge that you acquired to get the domain and the range of those simple and basic graphs. Okay, right. You've got something like this. You've got something like that. Call this x equal to 1, y equal to 3. Okay, just attempt these four, determining the domain, just attempt that. Okay, I've got this is 1 and 4. Okay, right. That's the activity that you can quickly look at, just applying the knowledge that I gave you. From there, please also follow us on EduBlush. I'm going to post more and more graphs that you also attempt and apply the knowledge to extract the domain and the range of these functions. Okay, right. Domain and the range of this function. Thank you for your time. Hope you acquired one or two things that are going to help you excel in this section, which is called functions and graphs. Okay, right. Now, in the next presentation, I'm just going to look at the inverse of a function, but graphically. Okay, thank you. Let's meet in the next class. Goodbye for now.